Hello, everyone. We're going to wait a few more minutes to see if more people join. So we'll start in 2 minutes. Thank you all for joining. Okay, so hello, everyone, and welcome to the webinar, Developing a Bankable PV Project with High Quality Irradiance Data. Thank you all for joining first, and let me start sharing with you all our today's agenda. The session will last for more or less 45 minutes. We will start with a brief intro on CleanPower research and RatedPower. Then we will learn about what parameters are generally considered when modeling solar PV to continue answering the question, what makes meteor data bankable? Finally, we will show you the power of PV design and solar anywhere working together. So please feel free to ask any questions throughout the webinar using the question box that you can see on your screens. We will try to respond as many questions as possible at the end during a Q&A session that we will have for about 10 minutes. So well, before we begin, let me introduce our guest for today. Please welcome Kristen Wagner, Customer Success Manager and Team Lead at CleanPower Research. Kristen works to support customer implementation of CPR's data products and to make sure you are getting maximum value out of them. Pleased to have you here, Kristen.
Yeah, thanks so much, Gabriel. So happy to be here.
Great. And well, myself, I'm Gabriel Canadas, and I will be hosting the webinar. I work at RatedPower as an account executive for the North American market, assisting our existing customers and looking for additional ones to help them reduce the LCOE of their PV projects. Kristen, so the floor is yours. Let's hear about CleanPower Research.
Awesome, thank you. So CleanPower Research is a software company that is headquartered in Kirkland, Washington. We offer 3 enterprise-level cloud-based software solutions that serve both the utility and solar industries. Today, specifically, we're talking about our solar resource data product, which is Solar Anywhere. So if you could just switch to the next slide. And Solar Anywhere is made to support your PV project across every phase of its life cycle. We offer historical data for solar resource assessment and PV performance estimation. We offer real-time data for systems operation and maintenance. And we also offer a forecast data product for system optimization. And today we are focused primarily on the Solar Anywhere historical data product and how it can be used in PV design.
So about RatedPower, we offer PV design, cloud-based software that carries out the design, engineering, and optimization of PV plants. With over 160 customers worldwide, we have helped developers, EPC, and engineering companies study and optimize more than 20,000 projects and 43,000 gigawatts of energy. PV design allows users to analyze and compare multiple locations while trying different equipment and engineering criteria to determine the best way moving forward for their solar projects. In addition, PV design incorporates an energy model independently reviewed by Black & Veatch to calculate the performance of these projects. So that's a little bit on us. Now let's start with the good stuff. So I have a few questions for you, Kristen. First, let's start with the basics. So normally meteor data is summarized in a TMY or typical meteorological year, right?
Right, that's correct. So typical meteorological year files have been used in the industry for a long time to generate PV production estimates. And they're also being used in PV design for this very reason. And the goal with a typical meteorological year file is to generate a year's worth of solar irradiance data that's representative of the standard or typical conditions at the site, so the typical irradiance and weather conditions. So you'll hear these files referred to as TMY files. You'll also hear them referred to as 8760s because they contain 8,760 hours, which is the number of hours in a year. So, yeah.
Great. So what meteor data is generally used to estimate solar production?
Yeah, so our Solar Anywhere typical meteorological year files include, we like to say, the components that you need for PV production and then nothing that you don't. They are built specifically for PV performance estimation. So the most important factors there are going to be your irradiance fields like GHI, DNI, and diffuse. And then we're also going to be including temperature, wind speed, elevation, relative humidity, in those files, as well as surface albedo, clear sky radiance, and particulate matter. So those can all be used as inputs into various PV production models. And Gabriel, if you'll actually go back to the slide prior, I want to explain a little bit more about how we generate the files. So Solar Anywhere typical year files are generated by selecting the months from the actual historical time series that are most representative of long-term average conditions at the site. And so because Solar Anywhere files are generated specifically for use in PV production estimation, specifically for solar applications, when we're generating those files and selecting the months to include, we're doing that with a focus primarily on the irradiance components itself. And so with the TGY file, which stands for typical global horizontal irradiance year, and that's the file that's going to be used in PV design if you're going to pull Solar Anywhere data in. We're generating these files with a focus on the GHI component. So for example, if you have a January of, say, in this image, it's showing 2000. So January of 2000 has the global horizontal irradiance monthly total that most closely aligns with the long-term average January monthly total irradiance from 1998 through 2021, as we have it now. Then that January is going to be included in the file. So you can see we're going to end up with 12 months of irradiance in the file that are selected from various years from the full historical time series. So that's a little bit on how we put those files together.
And how is this data collected or generated?
Yeah, so great question. Solar Anywhere data is a satellite-based solar irradiance model, and we used an industry-leading model developed by Dr. Richard Perez and his team at SUNY Albany. We work in close partnership with him to make consistent improvements to the model. And satellite-based models have a big advantage in that you can take advantage of the precision of the native satellite image resolution itself. So the data being used in PV design is at 10-kilometer spatial resolution, which corresponds to a pixel size in the satellite image of 0.1 by 0.1 degrees. And so that's really beneficial in that you can get and you can capture the site-specific characteristics of the irradiance and weather at your site, which is important. You're going to see some other approaches out there that are going to be using maybe nearest neighbor to assign the nearest set of ground measurement data to your location, or you might see approaches that are averaging the condition across large regions. And that's just not going to get you quite where you want in terms of understanding the actual climatology of your site. And so that our satellite data itself is generated in 3 steps. Those are outlined here in this slide. The first step is actually completely independent of the satellite imagery, and it's to calculate the clear sky irradiance at the site, or the irradiance in the absence of any cloud cover. And so the inputs to calculating that are going to be your solar geometry, so the position of the sun over your site at each time of day, as well as elevation, water vapor, ozone, aerosol optical depth, and temperature. So once we have our clear sky irradiance, we can move to step 2, which is to consider the satellite image. And the satellite image is going to show us the cloud cover over the location at each time step. We're collecting satellite imagery globally at every 30 minutes. And so we have, for each pixel, the cloud cover at every 30 minutes over the entire globe. We can quantify the cloud cover in that imagery into a value that we refer to as the clearness index, or KT. And then once we have that KT, we just apply it back onto that clear sky irradiance, and we can end up with our final estimated irradiance value. Yeah, so that's a summary of our satellite-based solar irradiance model.
Great, thank you for that. So much has been spoken lately about solar assets and underperforming, and investors getting concerned about this. So what makes solar meteor data bankable? So what makes this data more accurate so then these assets are going to perform as expected?
Yeah, absolutely. So we like to say there are 5 characteristics that classify a solar resource data set as bankable. Those 5 things are that it is validated, that it is spatially and temporally consistent, that it is spatially and temporally precise, that it's built specifically for solar applications, and that it has a known accuracy. And it's also available. So you have a period of record, a long period of record that also includes the most recent years and months of data. So I want to elaborate a little bit more on the validation and consistency specifically. I've touched a little bit on the other 3 as I've been talking, but in terms of the validation, the Solar Anywhere model is validated against over 500 reference years of ground measurements for both GHI and DNI. So in combination, that's over 1,000 reference years of high quality ground measurements that we're considering when we're validating the performance of our model. And those ground measurement stations are dispersed geographically, and they're also dispersed into a variety of different terrain types, so we can understand how our model is performing in a wide variety of locations and terrains, like in mountainous regions, in flat regions, and desert regions. Which is really important. And then on top of that, we're actually pulling in the ground measurement data and doing a lot of quality control on that data itself. Our research team works really hard on that. And that's because we're treating the ground measurements as truth in this case and validating our model against their performance. So we want to make sure that they are in fact as close to truth as we can get them, which does require a little bit of extra quality control oftentimes. And then another point I want to make about the validation is that while we're validating against these ground measurements, the ground measurements are not being used as active inputs to the model. So that gives you confidence that the model is performing that at that level independently of the ground measurements themselves. And so that leads me to talking a little bit about the consistency of the model. So once we have our validation done, and we have a good understanding of the uncertainty of the model, which for Solar Anywhere is plus or minus 4.5% globally at the 95% confidence interval. That tells us that we can be confident that no matter where we pull the data, no matter what 10-kilometer tile we pull the data for, it's going to perform at least that well. And it varies, based on site conditions and the complex climatology of the location, but in general, we have confidence that it's going to perform at least plus or minus 4.5%. And then it's also performing that well over time. So if you're looking at the entire 20+ year time series, you have a good understanding that the models doesn't have any strange trends in bias that are going on, and that it's actually performing consistently across that entire time period, which is important.
Great, thank you for all those insights. So I hope the audience is learning as much as I am. So I have one last question. After integrating Solar Anywhere and PV Design, what do you think are the benefits of having integrated data sources within a solar designing or modeling tool?
Yeah, that's a question that hits close to home for me. Serving as a customer success manager in this field for 3 years, I have come to understand the different pain points that the different stakeholders are experiencing as they're trying to make use of our data. And so one of the most frequent things that has come up is the need to download data in a specific file format. And there's all these different file formats used in different tools, and then needing to import that data into a tool using a specific methodology and file format. And that can cause a lot of mix-ups and confusion. And so it's really awesome to see like tools like yours that are integrating our data directly, so you can just log in, click one button, and boom, you have bankable solar resource data ready to use for your PV project.
Yeah, I completely agree. I think that that increases accuracy and reduces human error in a way. So having to download that data in a format, then exporting, importing, and then maybe having to make changes on those files to be able to upload them correctly to whatever tool you're using. So I think that's a very interesting point. And then also with just one click, so in the end you are reducing time to design or to model your projects. So you don't have to go look for the data, even if it's pretty straightforward. You don't need to unload it and then upload it again. So it's pretty straightforward. Just click and you're confident that that's going to work. And then in the case of PV Design, so it will actually allow you as well to easily compare different scenarios. So maybe using the same data source, or maybe even changing that data source to see how that would affect the performance of your projects. So these within PV Design, at least, it helps you a lot to understand better how any change you can make in your project will affect the performance of the same one. So yeah, I think that's good for now. Now I would like to share my screen, well, as I'm sharing right now, but PV Design, and show you a little bit how this integration works. So let me just make this full screen. Okay, so well, this is PV Design. For those that know the tool, for integrating, you would actually need to come to My Company Information and then go to the Integrations tab here. Here you will be able to edit. So we have 2 integrations for now, Solar Anywhere and Solcast. So for Solar Anywhere, you can click Edit, then input your API keys from the subscription you have with CleanPower Research. And then you would have the option as well to check this box that would actually load the data automatically for any project that you design with PV Design. If you don't check this box in the designing process, you would need to load that data for each case that you would like to use it. So I have actually prepared a case or business case here already for showing you this. So let me just access it. I have already done a few designs or iterations of a same project to then later show you how this compares. But let me show you the design process first and see where you actually select Solar Anywhere's data and how PV Design looks inside. So this is the designing process in PV Design. I've already loaded a KML file of my site. This will be in Australia. So once you've successfully uploaded your site, you can define the topography you would like to use, and then the meteorological data you'd like to use. Here we have different points that you can choose, and you have Solar Anywhere. I have already loaded it, but normally it would take less than 1 minute to actually load this specific data for the project. While this is loading, you can go through the designing process and work throughout it. And then once you generate the design, this would be already applied to your project. So in PV design, after selecting the meteorological data you would like to use, you would select the equipment that you want to simulate with. So PV module, inverter, the racking system. Then on the layout, you would define the different distances your power requirements first, and then the different distances and setbacks to define the layout within your project. Under topography, here we have a pretty interesting tool to actually analyze the topography of your terrain and do a cut and fill or earthwork analysis as well. Then under grid point, select or define the different parameters to size your substation or interconnection facility. Then under electrical, same thing, parameters to size the different cabling within your project. We have a battery storage system product as well in case you want to incorporate AC coupled battery storage within your project. And then for energy, this is more related with this topic. So here you would actually decide the number of years that you want to launch that simulation for, the internal variability as well for your P75, P90, P99 scenarios. Then the horizon profile you would like to use, albedo data as well. We are not yet integrated with Solar Anywhere, but we are definitely looking into that. Then the PV module losses you would like to include, PV plant losses as well. And then for more detail, you can play as well with some other parameters. Lastly, you would have this cost section. So here the idea is to create a pricing template. So then you can calculate the capex of your project. Once you're happy with your inputs, you can just click Generate Design, select the unit system and the language for the documentation that PV Design generates, and then just click Generate Design. Here we can see this little card loading. This will take about 1-2 minutes to load, so you can access the documentation, but I have already here a few examples, so we don't need to wait. So the good thing about PV Design as well is that you can actually compare these different scenarios. So if I've prepared using the same parameters, so same media data sources and same other parameters, other than the module that I'm using, that is the same module, but using monofacial or bifacial, and then for fixed tilt and tracker with the same module as well. So here, if I select all of these scenarios that I've created and I click compare, I can very easily see how any change that I've made from changing from tracker to fixed tilt or from mono to bifacial actually affect the output of my project. So I can here, for example, sort by the energy produced. So I can order it the most production. So obviously here is the bifacial with fixed tilt. I can sort by the price of my project as well, by the performance ratio, and so on. I have other parameters that you can use to compare as well in case you would like to use those. But I wanted to focus on these for now. And then as well, I have a few charts here that would actually help me compare these same projects, more focused on the energy and cost. So this is a little bit about this comparison tool. I would like to also show you as well the documents that PV Design generates. So here, let me just open this example. I have a list of documents that I can actually download after performing the design process with PV Design. Related to this topic, we probably have the energy yield report. This will be a 20-30 pages document summarizing your project, but focusing on the energy yield, on the energy production. And then we'll have as well the energy yield results. This would be an Excel file with the 8760 table. So let me just open those up so you can see them. So this would be an energy yield report. Basically, as I mentioned, here you would have the introduction for your project, then the site, so the location of your project and the main characteristics of your sites with your topography as well, then the horizon profile you've used, and then the solar resource. You would have here some information, so Solar Anywhere. Normally, the typical meteorological year that we use would be the P50. The surface albedo data that I've selected as well. A general description of your PV plant with the equipment that I'm using. And then at the end, the methodology that we've used. So if you have any questions on the methodology that we have behind PV design running our energy model, you can look for it in our website. It's accessible to all of you, so you can check that out. And then we have more detail on the specific losses on each type of loss for my project. And last, I would have my energy yield results. So the summary for my energy yield results for my first year P50, first year nighttime consumption, 25-year energy yield, because I selected to simulate P25 years, and then the probabilistic yield estimation for my other scenarios, P75, P90, P95, and P99. Additionally, let me just open the energy yield results. So this would be the file with my 8760 tables and my hourly production. Here in the first tab, I would have a summary of my project. So you can see we're using Solar Anywhere source. Then we'd have my hourly production for every hour of the number of years that I've decided to simulate. My hourly nighttime consumption as well for all those years, all those hours. And then the first year hourly in more detail. So I would have my sun position, my irradiance results, and the inverter results as well for the first year. And I would have the losses, 1224 tables as well. And then for the battery energy, in case I've included a battery that I haven't in this project. So, well, this is PV design, and this is how we mainly integrate with Solar Anywhere. So let me just go back to the slideshow. So then, of course, this is PV design in a nutshell, pretty fast. But if you want to learn more and participate in a demo or a free trial or have any questions, please reach out to us. We'll also be at the RE Plus, former SPI, in a couple of weeks at booth 1770. So feel free to drop by and we can further discuss any questions that you have. And then
I'll also add too that you can get started on this for free. If you go ahead and go to data.solaranywhere.com, you're able to register for a public account at no cost. That's going to give you access to our full data offering at a selection of locations globally. And you'll also get automatic API access to all of those locations. And so then you can generate an API key once you've registered, and then go ahead and input that into PV design and start testing it out.
Great. So I think that's all from us. Now we'll open the floor for any questions that you may have. So I already see here a few. Let me make this a little bit bigger. Okay, so I think this is for Kristen. So are there any KPIs, methods to assess the quality of satellite data sets, or to, I'm not able to read, hold on, let me make this bigger, or to compare two data sets?
Yeah, so I think basically when you're looking to compare two data sets, there are a couple of metrics you can look to, and hopefully the data set you're comparing against has a published validation document that provides, there are a few key error metrics that have been used for a long time in the solar industry to quantify uncertainty and quantify accuracy. These are going to be things like relative mean bias error, root mean square error, and then relative mean absolute error. So if you are able to get your hands on a public validation document from both sources, you're able to compare those metrics against each other. And then additionally, you do want to pay attention to the other factors that I mentioned when discussing bankability, because it's important that your data set also has a pretty extensive period of record and that it's consistent spatially and temporally, and in all of those things. So you want to pay attention to both the quantitative and qualitative factors of the data set.
Okay, so I have another one for you, Kristen.
Yeah.
So I would like to know about bias and uncertainties of Solar Anywhere model derived TMY datasets.
I'm sorry, I think I misunderstood the first part of the question.
Yeah, so I would like to know about bias and
Oh.
uncertainties. Bias, yeah. Solar Anywhere model derived TMY dataset. Bias, yes, sorry.
Oh, yeah. So the TMI data set has a known uncertainty of plus or minus 4.5%, but that is also at 1 kilometer, that's at 1 kilometer spatial resolution. And so when you start, looking at it at 10-kilometer resolution and you increase the space, it does introduce a little bit more variability into the performance. So the actual known bias of the TGY data set and TDY data sets is plus or minus 5% instead of 4.5.
Great. I have another question. I don't know if this one is for you, me, or both, but I'll ask you first. I think we already responded to this, but do you provide a trial? The results done during the trial period, can it be used for commercial purposes?
Yeah, so I guess our form of trial is the public data set, and it is actually our full data offering that you would get if you were to purchase a license with us, but it is limited in that it's at pre-selected locations across the globe. So yeah, so technically it is our bankable most recent data version, but it is site specific.
Okay, in our case, as I mentioned, we do provide a 14-day free trial for anybody that wants to try our software. So just reach out to us through our website, RatedPower.com. Of course, all of the documentation that is generated during these 14 days that you can download, and it's of your personal use, so you can do it for any purpose that you want. Okay. I have another one here. Is there a recognized classification of satellite data sets?
Classification.
Yeah, I guess like a ranking or something like that, or because it's mentioning Solar GIS, Meteorological, and so on.
Oh, okay. No, I don't think there's an official classification comparing the different irradiance sources against each other. But yeah, again, I would always try to go back to thinking about the qualities of the data you're looking at, because knowing that your data is trusted and accepted by like the IE community, et cetera, is really important. And then knowing that it does have those bankability characteristics is important. So there are different free data sets and things out there that you can use, and we find our customers often using those as a helpful benchmark and to understand, is our data at least in the ballpark of what we expect, that type of thing. But when it comes down to it and you're hoping to make a bankable PV assessment, you do want to make sure that the data set you're incorporating meets all of those standards.
Great. Then I have one for me, I think. How does Black and Beach, I lost the question again. So, well, I'm just gonna answer it. So yeah, Black and Beach carried an independent review on our energy model. In the end, what they did, they compare same simulations carried out in PVSys and in PV design, and then they compare the results, and we were really close to those results. They also made comments on where the main difference were. We were less than 1% away from those results in PVSys. So of course, this report it's available, and you can download it through our website as well. If you ask for it as well, we can share it with you. And then I had another one here that it was for both, I think. Sorry. Great. So then also I think this one could be for both of us. So if you buy one license, how many people can use it?
Oh yeah, so with one Solar Anywhere license, you get an unlimited number of users. So anyone on your team who wants to be able to log in and download data can do so. And that's all just, we have two license types. So some people in the license are classified as license managers, and they can add whoever they'd like to the license. And they can also generate API keys themselves to use in accessing the data programmatically.
Okay, in our case as well, we offer unlimited seats or users per subscription. These users will need to be from the same company. So in the idea, in the end, we do believe PV Design to be a collaborative tool where different users can access it, and they can see each other's projects and try to simulate in a different way or optimize in a different way each other's projects. So yeah, unlimited users as well. I think this one is for me. Does the table in the report get automatically filled out as well? Yes, so all the documentation that is generated in PV Design gets automatically populated, depending, of course, this would change depending on the inputs that you give to the tool. All of these documents come in editable format, so you can get it in DXF, so AutoCAD, Excel, or Word files, so you can actually make modifications yourself in case you want to tweak those, or you can download them directly in PDF. So I don't know if this was as well addressed to you, Kristen. I saw you nodding.
No, it sounded like a question for you, yeah.
Okay, perfect. So is there any other parameter than GHI taken into account when generating the TMY file, such as DHI, temperature, etc.?
Yeah, so actually the Solar Anywhere methodology places 100% of the weighting on the irradiance component in question. So if you are wanting to use a typical GHI year file, 100% of the weighting is going on the GHI. We also offer typical DNI year files where 100% of the weighting is on the DNI component. We don't place any of the weighting on temperature, but yeah, we find that the primary fields of importance in a modeling are the irradiance components, and temperature does have sort of a second degree of impact on the modeling. But we do select the actual months of data from the time series so that the temperature components that are selected for the file are the temperature conditions that were present and associated with the GHI components at the same time steps.
Okay. I have one for me. Do you have data sets of PAN files or OND files, I guess? So yes, we do have a very large public database within PV Design with more than 5,000 modules and more than 1,000 inverters. In any case, we do allow all of our users to upload their own equipment through PAN files and OND files. In case they're using confidential equipment, for example, or something just came out and is not yet available in PV Design. Anything you upload within the tool will remain only accessible to your company, and of course, it will be confidential. Okay, so one for you. Is there any reliable source for albedo and soiling for early stage design and we're not having ground measurements?
Yeah, and Solar Anywhere does offer both of these fields. And Gabriel briefly mentioned in the presentation that we hope to integrate those in the future. But essentially, in terms of the albedo data set, we are pulling those from a known satellite source and then also accounting for albedo and snowy conditions over the entire time series so that you have a fair representation of the snow in your albedo data set. And then with soiling, we're taking advantage of the particulate matter fields that we're pulling in and using those in a model that's trusted in the industry, known as the HSU model. There are always several limitations in satellite-based soiling data that just you can't quite capture all of the site-specific impacts. And this is definitely more representative of the atmospheric soiling. But we do offer quantifications of soiling losses that can be requested and downloaded in accompaniment with a license to our typical year data. And those are going to come in the form of a 12x1 that can be pretty easily input into your PV performance tool of choice.
Okay, thank you. I see a follow-up question on the PAN or OND. Let's answer that as well. So can you use custom PAN OND files? So yes, as long as it is a PAN OND format, you can change that, upload it into PV Design, and you can simulate with it. Then the energy yield report is generated immediately after the system design. So normally after you click generate design, the PV design will take around 1 minute to generate that design and to generate all of the documentation. Then you would be able to download it, and it will be available for you to download. Would it be possible? I think Emilio already responded this. I see many people asking about the recording. We will share this recording with all of you after this webinar, so probably early next week. And are you sending the reports? Again, if you contact us, we can arrange a call. You can try the software, download the reports, and we can also share a sample of the documents that PV Design generates. I don't know in your case, Kristen, maybe the same thing. No, I guess.
Yeah, no. We don't have a reporting feature at the moment, but.
A ver. Thank you for answering. Thank you very much. Okay, there's another one here. Do you have meteorological radiometric data from all over the world? Are there any region where you don't have any data?
Solar Anywhere is totally global at this point. So we offer data in every region. The only areas where you might have some trouble is like Antarctica. We have a cutoff of 60 degrees north and south. So
great. And do most all developers also initiate meteor station campaigns to be used for ground turning production, modeling, and subsequently project financing? Or do you think that the SA datasets, okay, this is, oh, I lost the question. Oh, okay, sorry. Or do you think the datasets are bankable by themselves?
Yeah.
Do you want to repeat that? Oh, okay, no.
No, I think I got it. So the Solar Anywhere datasets are bankable independently, and they can be used directly in solar resource assessment, PV production reporting. We do also offer, we have a partnership with a ground measurement station provider and maintenance provider in the United States called Groundworks. So we do a lot of these tuning reports within that partnership. So we use their data, and we have a tuning process that generates a solar resource assessment report that gets delivered directly to the customer for use as a bankable report. But we do believe that our data is bankable independently of ground measurements. Ground measurements can just provide that extra amount of reduced uncertainty if that's needed.
Okay, one for me. Does PV Design have a Sankey diagram waterfall chart? Yes, we do. Here you can actually, hold on. I'm still sharing my screen, right? So here, once you create the report, you can actually, under energy, see the different losses and see how that goes down. In the report, you also have, I already closed that, but you would also have this table. And yeah, I think I have one for you. Is Solar Anywhere hourly data based on 5 minutes satellite photo snapshots or 30 minutes? How is this hourly data produced from this hourly satellite photos?
Yeah, so we have two historical data products. The main historical data product in the full time series historical data is being generated from the 30-minute resolution satellite imagery, and then that's average to hour ending averages for the hourly resolution data, and that's the data set that's getting used for the typical year files. However, we have also recently been able to take advantage of the 5-minute resolution satellite imagery provided from the GOES satellite network in the United States. And so we've used that imagery in addition to a variability enhancing mechanism to provide a 5-minute resolution data set that can be used for like clipping loss applications or battery sizing applications. But that is sort of a separate product. So for the main historical data sets, we are taking advantage of the 30-minute resolution satellite imagery.
Great. Did you manually enter the monthly albedo values, or was that extracted from the Solar Anywhere files directly? The hourly file would provide the albedo values for each time snap. Reason why I'm asking is if the software calculates the monthly value or if it's something you do manually. So we are yet not integrated in this aspect with Solar Anywhere. So we do expect to build on our relationship and include this in the future. With regards to PV design, we do have some available satellite data sources for albedo with different monthly values. You can also fix a yearly value for all year around, or even create your own profile with monthly resolution. And you would need to do this manually yourself. And I think that's pretty much all the questions. Yeah, I think that's most of them. I don't know, maybe I'm missing some. I see here many, and I've been jumping in between them through the most interesting ones. So if we haven't answered any of your questions, please, my apologies. You can always send us an email and we can respond them. I think all of these questions are saved, so we will get them after the webinar. So if we haven't responded any of these questions, we'll try to get back to you next week. So I think that's pretty much all. Kristen, I don't know if you wanna say a few last words.
No, I don't think so. This was really great. It was great. It's been awesome working with you all. Perfect.
Yeah, same from me. Thank you everybody for joining here today. You will be receiving the recording, so no worries. We will try to answer all of your questions. It's been great working with CleanPower Research and other teams. So thank you very much, and hope to see you again soon.
Yeah, thank you everyone for joining.